What is discontinuous conduction mode in DC-DC converters? Imagine a light switch that turns on and off, but sometimes it stays off for a moment before turning back on. That's similar to what happens in discontinuous conduction mode in DC-DC converters. When the converter is working, an inductor stores energy when the switch is on. Usually, in continuous conduction mode, the current through the inductor keeps flowing steadily without dropping to zero. But in discontinuous conduction mode, the current actually drops to zero during part of the switching cycle. This happens mainly when the load is very light or the inductor is small. In this mode, the energy stored in the inductor during the switch-on time is just enough to power the load and cover losses for one cycle. Once that energy is used up, the current falls to zero before the switch turns on again. During this period, no current flows through the inductor. This creates a gap in the current flow, which is why it's called discontinuous conduction mode. It is common when the load demand is low, or the inductor value is not large enough to keep the current flowing constantly. One key feature of discontinuous conduction mode is that the waveform of the inductor current drops to zero and stays there for part of the switching period. Because of this, the duty cycle, which is the ratio of the switch on time to the entire cycle, tends to be smaller than in continuous conduction mode. The output voltage depends on the duty cycle and the inductor and load parameters, making the behavior different from continuous operation. Another characteristic is that the peak currents and ripple in the inductor and switching devices tend to be higher in discontinuous conduction mode. This can cause more electromagnetic interference, or EMI, because of the sudden changes in current. Sometimes, the output voltage can oscillate a little during switching transitions, especially in sensitive power systems or renewable energy setups. Understanding discontinuous conduction mode is important for designing efficient DC-DC converters that work well across different loads. When designing, engineers choose the right inductor size, switching frequency, and control method to switch smoothly between modes. This helps keep the output voltage stable and reduces stress on the components. In summary, discontinuous conduction mode occurs when the inductor current drops to zero during part of the switching cycle. It mainly happens at light loads or with small inductors and influences the efficiency, electromagnetic behavior, and overall performance of the converter. Recognizing this mode helps in designing better power systems, especially in renewable energy applications where load conditions can change quickly.